Good morning to all the participants. Let us start today's session. Today we are going to discuss time value of money. Time value of money. So what is it? Let us look at it. Now you know this is 100 rupees note. 100 rupees note. This 100 rupees, we call it face value of the money. This is face value of money. This face value of money always same. Now it is 2020, it is same. Last year 2019, same. Maybe 2000 it was same. Maybe 1950 it is same. Similarly, maybe 2025 it is going to be same. The face value of the money is same. Right. Then what is happening? I must tell you, there is no handout for this session. So I will be explaining everything on the board. You have to take it down, one thing. And we will do some problems, some calculations. You have to do those calculations with me. Yes. So for that, you must have a calculator and papers, pen, etc. The calculator, even an ordinary calculator, is enough. Apart from that, if you have a scientific calculator or anything, yeah, that is your wish. But yes, an ordinary calculator is enough. So these things you must have. Once again, I am telling you, today's session, there is no handout. So you have to follow everything with me here. Okay. So now it is 2020. Last year, 2019, 2018, it goes on, 2017, it goes on like that. Now, next year is going to be 2021, 2022, it will go on like that. Now, face value of the money, what I told you, face value of money, 100 rupees. It is 100 rupees. 100 rupees. 100 rupees. In future also, it is going to be 100 rupees. Face value of the money, 100 rupees. So now, with this money, when we try to purchase bread, now a loaf of bread, a pound of bread is 65 rupees. So with this 100 rupees, you can buy about 1.5 pound of bread. And buy. Maybe in 2018, the loaf of bread was around 60 rupees. Loaf of bread was around 60 rupees. So you would have bought about 1 3/4 of pounds of bread you would have bought. Bread. Maybe 2017 or 2016, it was about 50 rupees a pound of bread. So you would have bought 2 pounds of bread. Now you are buying with 100 rupees, 1.5 pounds of bread. Maybe 2021 or 2022, you may buy only 1 pound of bread. What is happening? What is happening? The purchasing value of money is getting reduced, diminished. The purchasing value of the money is getting diminished. While the face value of the money remains same, the purchasing value of the money is getting diminished. We call it as real value of money. Once again, I repeat, while the face value of the money remains same, 100, the purchasing value or the real value of the money is getting diminished. This is what we are calling as time value of money. Please take it down. While the face value of the money remains same, while the face value of the money remains same, the purchasing value or the real value of the money is getting diminished over a period of time. This is what we call it as time value of money. In other words, if we explain more, the money what you have today, the amount of money what you have today is worthier than the same amount of money you may receive at a future date. So please take it down. In other words, the value of money what you have today, the value of money what you have today is worthier than the same amount of money you may receive at a future date. At a future date. So what you have today is worthier. The money what you have today is worthier than the same amount of money you may receive in a future date. So there is an English proverb: the bird in the hand is worthier than two in the bush. The bird in the hand is worthier than the two in the bush. So this is time value of money. So why we consider it more? Why it is important for us? Right. Now we are doing some investments. We are doing some investment. So we are going for some projects. Investment. Capital investment. So we are investing. Then following years you are getting the income. So now you are investing, say about 5 million rupees you are investing today. And then the following years from the investment you are getting income. So those income, the value of the income, the real value of the income is not equal to today's one. So you may see, right, I am getting this much of income. I am getting more than what I have invested. But in the present day, present value, when you convert, it may be not true. It may be not so. So you have to analyze and see. So because of that one, the time value of money is very, very important. Then there are two terms in the value of money. But is today the value of money, we call it as present value. PV, in very simply, we call it as present value of money. What you have today, the value of money, what you have today, you can call it as present value of money, PV. What is the amount of money? The amount of money what you are going to get in future date. In future date, that is future value. Future value of money, FV, we call it FV. So these two terms, present value and future value of money. Future value of money, what you are going to get in future. What you are going to get in future. Future value. Present value of money, what you have today. We can explain these things further, but first of all, we understand the meaning of present value and the meaning of future value of money. The future value of money, what you are going to get in future. Present value, what you are having today. Right. Well, I am going to erase the board. When there is a question, what you understand by time value of money, all these things you must write with the example. I have given you an example with bread. So you any item you can give as an example. And the meaning of time value of money you have to explain. Right. Okay, now we go. Today, for the meaning, so say some project years, some project, so investment we are going to do. Then we mention 0, it is today. Now, when we mention 0, it is now, today. Then from today, after 12 months, year 1, similarly, year 2, year 3, year 4, it goes on. It goes on. Any investment, when we are doing today, we mentioned today, that is year 0. Then from that investment, we may get some income or whatever it is, year 1, year 2, year 3, with an interval of 12 months. Right. Now, I have 1 rupee, so that is PV, 1 rupee I have. I want to invest this money with a bank on a fixed deposit. Okay, with a fixed deposit at an interest rate of 12%. So, interest rate is 12% per annum. And that investment with an automatic renewal. Fixed deposit with an automatic renewal. That is what will happen. Today 1 rupee, then following year the interest on that 1 rupee. Total, that is will be the capital for the next year. On that one interest, again on that one interest, it is interest on interest basis. We call it automatic renewal basis. We are investing. Right. So now we are having fun. You must know if the interest is 12% per annum, you can mention it as in decimal, that is 0.12. Interest percentage, 12% per annum. When you mention it, it is 0.12. So for 1 rupee, for an year, you will get an interest of 0.12 rupees. So with the interest, the capital will become as 1 plus 0.12. Okay, right. So in the first year, now it is 1 rupee. In the first year, it will become as 1 plus 0.12. This is the capital, 1 rupee plus 0.12, the interest earned on this capital of 1 rupee here. I told you it is on automatic renewal. Then what will happen? This is going to be the capital for the next year. This is going to be the capital for the next year. So next year, then what will happen? This capital will be there plus interest on this capital. This capital will be there plus interest on this capital. So next year, it will be 1 plus 0.12. This is the capital portion plus interest on this capital. That will be 1 plus 0.12 into the interest, that is 0.12. This will be in the second year. This is the capital portion in the second year. This is the interest portion on the second year. So this will be. Once again, I will repeat it. Now, today I am investing 1 rupee with the bank at an interest rate of 12% per annum. In decimal, for 1 rupee, it is 0.12 rupees. Right. So, in the first year, that 1 rupee will earn an interest of 0.12 rupee. So, it will be 1 plus 0.12. In the second year, this is going to be the capital. So at the end of the second year, this capital will be there. That is 1 plus 0.12 plus interest from this capital will be there. That is, interest portion is 1 plus 0.12 into 0.12. If you calculate 12%, put in 100 rupees, you will get this one. So this is the interest portion. This is the capital portion. Now we simplify this. We simplify. That is factorization. You would have learned in your maybe mathematics, algebra, 4th standard or 5th standard. You would have learned this factorization. There's a common factor. 1 plus 0.12 here, 1 plus 0.12 here. So this 1 plus 0.12, automatically there will be 1 will be there. 1 into. So if you put 1 into 1 plus 0.12, it is same. So common factor you are taking out. 1 plus 0.12 you are taking out. When you take this one out, there will be 1. Even if you put 1 and see, it won't make any difference. 1 will be automatically there. If you put 1, it is same. If you put 2 or 3 only, it is different. 1, it is same. So 1 is there. So if you take 1 plus 0.12 out, 1 will be there. Then this plus will be there. 1 plus 0.12 you have taken out. So 0.12 bracket close. So this will become that 1 plus 0.12 into 1 plus 0.12.
Excuse me, sir. The video has gone off.
Sorry?
We cannot see the video.
You can't see the video?
No.
We can maybe.
Okay. Yes.
Now right.
Now it's okay?
Now it's fine.
Please repeat it.
Now it's fine. I can see now.
Okay. Fine. So now further you can simplify this. Is equal to 1 plus 0.12 into 1 plus 0.12. It is 1 plus 0.12 to the power 2. So in the second year, this 1 rupee what we are investing now will become as 1 plus 0.12 in the first year, and it will become as 1 plus 0.12 to the power 2 in the second year. Now we go to the third year. What will happen in the third year? In the third year, this is going to be the capital. This is going to be the capital. And it will earn interest on this capital. So 1 plus 0.12 to the power 2, this is the capital, plus interest on this capital, that is 1 plus 0.12 to the power 2 into 0.12. This is the interest portion, this is the capital portion. This is the interest portion. So this one will come as the capital for the third year. Plus interest on this capital. So we can simplify. Here 1 plus 0.12 to the power 2 is the common factor. Take it out. 1 plus 0.12 to the power 2 is a common factor. When you take it out, then bracket, when this one is coming out, there will be 1. By putting 1, you won't make any difference. So it is 1 plus, when you take this one out, 0.12 to the power 2. Sorry. So when you take this one, 1 plus 0.12. So further simplify, this will become as 1 plus 0.12 to the power 3. In the third year, what we are investing now, 1 rupee will become as 1 plus 0.12 to the power 3 in the third year. In the fourth year, it will be 1 plus 0.12 to the power 4. Fifth year, 1 plus 0.12 to the power 5. In the nth year, it will be 1 plus 0.12 to the power n. In the nth year. So today is 1 rupee. The present value of 1 rupee, PV is 1 rupee, present value. In the nth year, it will become as 1 plus 0.12 to the power n, the future value. Today's the PV is 1. In the nth year, it will become as 1 plus 0.12 to the power n. So this is the future value. So this is the present value. When the present value is 1, the future value at the end of the nth year will become as 1 plus 0.12 to the power n at the interest rate of 0.12 or 12% per annum. Let's take it down. I won't erase it. Okay, I'm going to erase it. I am repeating. So the future value is equal to 1 plus 0.12 to the power n. In this example, what we have done, in this example, the future value is equal to yes. So in this example, we took it as 1 rupee as the present value. And the interest rate as a 12% per annum or 0.12 in decimal. So in this example, in this formula, you have to use the interest rate as a decimal. In this interest rate, you have to use the interest rate as a decimal. So when we can make a common formula, that is future value is equal to, this is for 1 rupee. So if it is for 100 rupees present value, then you have to multiply by 100. If you have 1 million rupees as the present value, you have to multiply this one by 1 million rupees. Now, because this is for 1 rupee, we have done this formula. This is for 1 rupee. So future value is equal to what you are investing today, present value into 1 plus interest rate in decimal. We call it as R to the power N. This is the formula. This is calculating the future value from the present value. Calculating the future value from the present value, where FE is the future value and PV is the present value. 1 plus R is the interest rate in decimal and N is the number of years. So this technique, we call it as compounding. Compounding. So what is compounding? Please take it down. It's a technique. Please take it down. Compounding. It's a technique converting present value to the future value. Compounding is a technique converting present value to the future value. Here the R is the compounding rate. Compounding rate. So the next one, what is compounding rate? Compounding rate is the interest rate applied in the technique of compounding. R is the compounding rate. Is the interest rate applying in compounding technique. That is compounding rate. Compounding rate. The N is the number of years. N is the number of years. Maybe end of 1 year, or maybe end of 2 years, or maybe end of 5 years, or maybe end of 10 years. N is the number of years. Okay. There's another thing I want to say. Now I have told you about compounding, the meaning of compounding. Compounding rate, I have told you what is compounding rate. Now there is another thing, compounding factor. Compounding factor. There is another term, compounding factor. What is compounding factor? When you use 1 rupee as the present value, what is the future value you are getting? That is compounding factor. So that is when it is 1, when the PV is 1, the FE is compounding factor. When PV is 1, the FE is compounding factor. But you will get so many compounding factors when R changes, N changes, you will get compounding factors. Different compounding factors. When the interest rate changes, when the number of years changes, you will get varying compounding factor. So the compounding factor, what is compounding factor? When the PV is 1, when the present value is 1, the future value is called as compounding factor, and it differs at different interest rate and different periods. I hope it is clear. So now the compounding factor, I told you, you will get numerous compounding factors. So when the PV is 1 for different interest rate for different period. Yes, there is compounding table. There is compounding table. There is compounding table. Compounding table. Like the table you would have studied in your maybe ECO level, or maybe before that one. Logarithm table, slope table, like that. People who have done mathematics, trigonometry, tangent, cotangent, sine table, cosine table, trigonometry. There are so many tables. Similarly, there is compounding table also. So from the compounding table, by going through the compounding table for different interest rate, for different period, what is the compounding factor? You will calculate. So compounding table, when you take the compounding table for different interest rate, for different period, what is the compounding factor? And then you use that one to calculate what is the future value. That is one way calculation, compounding table. But anyway, even without the compounding table, we can do this calculation. Right. Now, there's a small exercise. Let us do. PV, 5,000 rupees. R, interest rate, we take 12% per annum. And 5 years, that is, the customer is depositing 5,000 rupees with your bank in the fixed deposit at an interest rate of 12% per annum with the automatic renewal. At the end of 5 years, how much you will get, how much the customer will get. Okay, right. So now, by using the compounding table, you can calculate what is the compounding factor. So compounding factor is for 1 rupee of present value. What is the future value? So by using 12% interest rate, at the end of 5 years, here what is the compounding factor? With the compounding factor, you multiply this one. You will get how much he will get. By going through the compounding factor, calculate, you take the compounding table. Yeah, what is the interest rate? 12%. And what is the period? Yes, the compounding factor is there. Right. Then you multiply the PV, you will get the answer. That is one way. And another way, what we are going to do, so future value is equal to PV, okay, I will write the formula, into 1 plus R to the power n. So here 5,000 into 1 plus R is 0.12 to the power n is 5 years. So this is equal to 5,000 into 1 plus 0.12, 1 into 1 plus 0.12, into 1 plus 0.12, 3 into 1 plus 0.12, 1, 2, 3, 4 into 1 plus 0.12. So by using your calculator, you can calculate this. By using your calculator, you can calculate this. In this simple calculator, by using this simple calculator also, you can do it. So in this simple calculator, there is a facility. I don't know whether you know. Right. Now, 2 into 5. You are putting 2 and then into sign and then putting 5 and then equal sign. Put in the equal sign, you will get 10. You will get 10. Again, you want to multiply by this 10 by this 2. So again, what you have to do, putting 10 into 2 equal sign? No. Just press equal sign, this automatically get 20. Again, put equal sign, this multiply automatically, you will get 40. Again, put equal sign, you multiply 80. It goes on. This facility is there in this calculator. Some calculator, it is other way. What is the other way? When you press, you will get 10. When you press 10, this 5 will multiply. So you will get 50. Again, you put equal sign. This 5 will multiply 250. It goes on. Either this one will multiply the answer or this digit will multiply the answer. So you must check your calculator, what type of calculator is. So you can use this one for our calculation. You can use this facility in this ordinary calculator for our calculation. Right. Now, if you have a scientific calculator, mathematical calculator, yeah, you can use it, no problem, fine. But if you don't have, if you have with only this simple calculator also, you can do it. That's what I am telling you. Right. So this facility is there. So in this calculator, what I am using, right. Okay. Now, what I put 2 into 5. 2 into 5 equal sign, I get 10. Again equal sign, I get 20. Again equal sign, I am getting 40. Again equal sign, I am getting 80. Again equal sign, I am getting 160. So that is, this one is multiplying the answer. The first digit I put multiplying the answer, it goes on. Is there facilities there in this calculator, ordinary calculator. So you must find out first what type of facility it has. Right. Now we use that one. So this is equal to 5,000 into 1 plus 0.12, 1.12 into 1.12 into 1.12 into 3 times into 1.12, 1, 2, 3, 4 times into 1.12, 5 times. So I clear it. Memory also there, clear the memory. Right. 1.12 into 1.12, 2 times I put it. Plus equal sign, I got 1.254, so 2 times. Again, equal sign, 3 times, 4 times, 5 times. I am getting 1.762. 1.762. I am getting 1.762. So multiply is 1.762 into 5,000 into 5,000. Actually, this is the compounding factor. for this interest rate and for this period. If you would have used the compounding table, you would have got this one. So now multiply by 5,000. 1.762, 1.762 into 5,000. 8,810 rupees, 8,810. So by depositing 5,000 rupees at a automatic renewal fixed deposit at the interest rate of 12%, the bank at the end of 5th year, we will get 8,810. So this is the future value. For the present value of 5,000 at the interest rate of 12% at a period of 5 years. So this is converting the present value to the future value, compounding technique. Compounding technique. Okay, we do one more exercise on this one. I hope this will be clear to you all. I will give you a few minutes for you to 1 or 2 minutes for you to just assimilate. So this is the compounding factor you would have seen in the compounding table. I hope everyone can see the board. I hope everyone can understand it. It is very simple, basic mathematics. You would have learned in your 4th standard. I hope. Okay, I will erase it now. ₹20,000 PV, interest rate of 15% per annum, maybe 6 years period. Putting 20,000 in a fixed deposit at an interest rate of 15% per annum with automatic renewal for 6 years. With automatic renewal for 6 years with the bank. How much that person will get at the end of the 6th year. I will give you a few 1 or 2 minutes for you to do it yourself, and then I will do it. F is equal to PV. F is equal to, please you better do it. PV 20,000 into 1 plus 0.1 plus 0.15 into 6. So that is equal to 20,000 into 1 plus 0.1 plus 0.15 into 1 plus 0.15 into 1 plus 0.15 into 1 plus 0.15 1, 2, 3, 4 into 1 plus 0.15 into 1 plus 0.15 1, 2, 3, 4, 5, 6. This is equal to 20,000 into 1.15 into 1.15 into 1.15 into 1.15 into 1 into 1.15. Okay, I will do it. So 1.15 multiply 1.15 by 1.55 for 6 times. 1, 2, 3, 4, 5, 6. So in this simple calculator, 1.15 into 1.15 2 times equal sign 2 times, then 3 times, 4 times, 5 times, 6 times, 2.313. So into 2.313. So this is the compounding factor. So I have taken 3 decimal points. When you take more decimal points, the accuracy is more. The accuracy is more when you take more. But when you do in the exam, you can take 5, 6 decimal points. Maybe if you take 3 decimal points, okay. Okay. Right. So this is equal to 20,000 into 20,000 into 2.313 is equal to right 20,000 into 2.313 is equal to 46,206. 213 is equal to 46,206. So at the end of 6 years, the future value of this present 20,000 at the interest rate of 15% will be 46,260. So that customer will get this much of money at the end of 6th year. At the end of 6th year, by depositing this money on a fixed deposit with your bank at this interest rate of 15% for a period of 6 years. Now, so when a customer comes to you, actually you are working in the bank, you may be in the fixed deposit division. So if the customer comes and asks you, Mahatya, Mama, 1 million deposit karut fixed deposit එක දැම්මොත් අවුරුදු පහකට පස්සේ කොච්චරද මට හම්බ වෙයි කියලා ඇහුවොත්, so you can simply say sorry, අපේ system then down, නැත්නම් system වැහුවා, දැන් නම් කියන්න බෑ, හෙට එන්න අනිත් අය එන්න කියලා කියන්න බෑ. If you have a simple calculator with this one, if you know your interest rate for the fixed deposit, then and there you can calculate and tell the customer. So you don't need to depend on the computer system. This is with a simple calculator. Now, if you have a cable desktop computer or the laptop computer also, you can simply calculate. Even without that one also, with a simple calculator, you can do your calculation and tell your customer. Even if somebody knows that you are working in a bank, if they come to your home also, if they inquire, if a known person come and casually ask how much I will get with this ordinary calculator, you can calculate and tell them. So you don't need to depend on the system. Yes. So this is compounding. I hope you have got the message. You have got it. I believe. Okay. Now I am going to erase this. This is compounding. FV is equal to PV into 1 plus R to the power n. This is compounding formula. That's what we have done. Compounding formula. Converting PV into FV, future value. Converting present value to the future value. Right. So this is okay now. Yeah. Now we go on to another area. Now I told you today in the project years, some investment you are doing in a machinery. So when you are doing this year 0 now, then year 1, year 2, year 3, year 4, it goes on. So now you are investing some money. You are investing in a machinery or in a project, you are investing. So maybe you may get sometime income from this investment, or sometime you may not get. Okay, we leave it. The second year you are getting income. Third year also you are getting income. It goes on. Goes on. So this is the present value. These are all future values. At the end of second year, at the end of third year, at the end of fourth year, it goes on. Now we must see whether your investment is worthwhile, worthy investment you have made. Whether you have made a worthy investment. That means what you are getting in future years is covering your investment. What you are earning in the future years, whether it is covering your investment and give you surplus. Whether it is covering your investment and it gives you surplus. We have. So this is project investment financial analysis. Or in other words, we call it as a capital budgeting also. Capital budgeting. Project financial investment analysis or capital budgeting, you can call it. Once again, now you are making some investment now. That is in the project year 0, and you are getting income in the future years. Yes, yeah. But actually you must check because of time value of money. These are future values, but we have invested in the present value. Whether these future values really cover our present value. You have to calculate it and see it. Then only you can be sure this investment is worthwhile. So what you have to do, this is the future value. I told you what we have in future, what we have today is worthier than what we'll have in the future, the same amount in the future. So what you have to do, you have to convert this one to the present value. You have to convert this future value to the present value. You have to convert this future value to the present value. Totally. And see whether this total is more than this present value. If it is more than this present value investment, the project is worthier. If not, the project is not worthier. I will give you little time for you to assimilate, try to understand what I said, try to understand what I said. In almost all projects, you are investing now and you are getting income in the future years. And as per the time value money, what you have today is worthier than the same amount what you receive in future. So, but in the projects, in the investment, you are getting the future money. So, whether that future money, what you are getting in real term, whether it covers your investment and give you the surplus, then only the project or the investment is worthy. Otherwise, it is not worthy. So for that purpose, what you have to do, you have to convert all your future money, future values. Convert all your future values to the present value. One by one, this one convert it to the present value, convert this one to the present value, convert this one to the present value, total it. We call it, so this is future value, converting to the present value, converting to the present value, converting to the present value, total present value, and see whether this total present value and this value, we call it net present value. NPV. That is converted all these present value and add to the present value. And deduct the present value what you have invested. So this is what you have got converted to the present value, and this one, this present value, get the net. This is the outflow and this is the inflow, get the net. So we call it net present value. If the net present value is positive, that is, these values are more than the investment. What you are getting in future years converted to the present value, the total of this present value, if it is more than the invested value, then it is positive, then the project is worthy. If it is negative, project is not worthy. When the net present value is positive, project is worthy. When the net present value is negative, project is not worthy. Okay, I will erase this. Kindly make your note. You have to make your note where there is no handout. I am erasing it. So now what you have to do, from the future value, you have to calculate the present value. You have to convert the future value to the present value. You have to convert the future value to the present value. So make PV as the capital. PV is equal to FE divided by 1 plus R to the power N. PV is equal to, you have made this simple mathematics, you have learned in your lower grades. PV is equal to FE divided by 1 plus R to the power N. So this is the discounting formula. We call it as discounting. That is converting future value to the present value. Now there is a new term, discounting. Discounting is a new term. Please take it down. What do you mean by discounting? Discounting is a technique. Discounting is a technique converting future value to the present value. Discounting is a technique converting future value of money to the present value of money. And here the R, we call it as discounting factor. This is the discounting formula. Please take down this discounting formula. This is the discounting formula, where the R is the discounting rate. That is the interest rate. What is the discounting rate? It's the interest rate applicable in discounting. Interest rate applicable in discounting is called as discounting rate. The interest rate applicable in discounting is called as discounting rate. Right. So this formula I can write slightly in a different way. PV is equal to FE I am taking out into 1. We've been taking out 1 divided by 1 plus R to the power N. Or otherwise, without that bracket also you can write FE, you are taking this FE out into 1 upon 1 plus R to the power N. This also you can write. See? And this is this portion is discounting factor. Discounting factor. So if the FE is 1, if the FE is 1, that the future value, if you are getting 1 rupee, if 1, then PV is equal to this. PV is equal to this. So that is discounting factor. So please take it down. What is the meaning of discounting factor? When the future value is 1 rupee, when the future value is 1 rupee, the present value is called as discounting factor. When the future value is 1 rupee, the present value is called as discounting factor. And this discounting factor differ like the compounding factor. This discounting factor differ with different interest rates and different period. So when the FE is 1, the future value is 1. The present value is going to be discounting factor. So the discounting factor, you will get different values depending on the number of years and the different rates applicable discounting rate. As I told you earlier, for the compounding factor, for the discounting factor also, you have discounting table. You have discounting table. For different rates, for different period, discounting different discounting rate. So you can see what is the discounting rate and multiply the PV. You can multiply the FP and you will get the PV for that value. So now this is FP. So this is the discounting factor. From the discounting table, you can see what is the discounting factor. From the discounting table, you can calculate the discounting factor, multiply the future value, and you will get the present value. So if you are having discounting table, from the discounting table, what is the interest rate, what is the period, you can calculate that. You can find the discounting factor and multiply the future value. You will get the present value. You can convert the present future value into present value. So this is the formula. PV is equal to FE into 1 divided by 1 plus R to the power n. So we have derived this formula from this compounding formula we have derived. So now you know what do you mean by present value, what do you mean by future value. That is one thing. What do you mean by time value of money? What do you mean by time value of money? Then you know what do you mean by compounding, compounding rate, compounding factor. Now you understand. Similarly, what do you mean by discounting? Discounting is a technique converting future value into present value of money. Compounding. Then what is the compounding rate? The interest rate applicable in compounding technique is the compounding rate. And now you know compounding factor. Compounding factor. Sorry. Discounting factor. Now you know discounting factor. When the future value is 1 rupee, the present value is called as discounting factor. This varies with the different discounting rate for interest rate and different periods. You have a discounting table. So this is the one. I hope it is clear with you all. Now, I am going to erase this. Please, you have to take it down. You have to take it down because there is no handout. Now, once again, we go project years. Year 0, that is now 1, 2, 3, 4, 5. Yeah. Now you are investing. Investment. Then first year you are not getting anything. Thereafter you are getting, over a period of time you are getting. Yeah. To see whether this investment is worthy, I told you what we had to do. You have to convert these future values to the present value. You have to convert this future value. So for that purpose, first what you will do, you will calculate the discounting factor at the interest rate for the second year. What is the discounting factor? So discounting factor. Then similarly, third year, you must calculate the discounting factor. What is the discounting factor in the third year at this interest rate? Similarly, discounting factor for each year, you must calculate the discounting factor. I have told you the discounting factor is the present value for 1 rupee of future value. For 1 rupee of future value, this is the present value at different period, at different interest rates. So now you calculate a discounting factor, and then this is for 1 rupee of future value. And then multiply what is the future value. Multiply. 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 You will get the present value. So to convert the future value into present value, first you calculate the discounting factor. First you calculate the discounting factor. And then for each period. And then multiply. So discounting factor means? Discounting factor is the present value for 1 rupee of future value. 1 rupee. At different period, at the interest rate or discounting rate. So now you multiply the future values. What are future values you are getting? Multiply. That will bring you the present values. This is the total present value of the income. This is the total present value of the income. Then you will get the total present value of the income and the investment. That is already in the present value. What is the difference? Whether it is positive or negative. We call it NPV, net present value. Net of this investment and income in present values. If it is positive, yes, income in present value is more than the investment. Very good, worthy. If it is negative, income in present value is less than the investment. Not worthy. That is present, net present value. So this is the basics of discounting. I hope it is clear. I will erase this. Some questions have been uploaded. I think you may have that one. So please refer that uploaded some questions, calculation, what we are going to do. Please look at that one. Question 1 is a theory question. In that one, what do you understand by the following terms? Time value of money, yes. Then discounting, yes, but you have. So wherever possible, please give the examples. And the net present value in PV. This is some theory question you have here. And then question number 2, 1 minute. I will read the question. Question number 3. You also would have read by this time. A company wanted to invest rupees 60 million in plant and machinery required for its new industrial project. The company plans to borrow this money from a bank at the prevailing lending rate of 18% per annum. The lifetime of the plant and machinery has been estimated as 12 years. However, company plans to sell it after 5 years of operation for a value of rupees 24 million. It is estimated that the project will bring a net cash flow of rupees 15 million each year during the first 5 years of operation. Apply discounted cash flow and justify whether the proposed new investment is beneficial to the company. Discounting tables will not be provided. You may use ordinary numerical calculators for this purpose. Right. So this is the question. So for this one, we call it investment financial analysis, and the company is investing a machinery and the company is getting an income. So there is an investment and then the income. So there is a cash outflow, that is as investment, cash outflow as an investment, and cash inflow as the income. So we have to have a cash flow for investment analysis. We call it, you must construct a cash flow for investment analysis. So cash flow for investment analysis. And you must mention in what currency you are using it. In Sri Lankan rupees million. So our calculation is shown in million. So cash flow, then of course so there will be a period. So we put it as project period. Year 1, that is now. Year 0, that is now. Year 1, 2, 3, 4, 5, and 6 project years. Now, so cash flow, you have to construct a cash flow. When you say cash flow, there will be an inflow. So what the project is getting, inflow, and there is an outflow, cash outflow, but the cash is going out of the project as an investment. Yes. And then the net flow, that is cash inflow minus cash outflow, we call it net flow. We must get the net. So cash inflow, first we say cash inflow. Here 0, no income. And it is a, from the investment, the company is getting 15 million net flow. 15 million net flow each year for first 5 years. So there the net flow means their income minus expenses. When you have an industrial project or some industrial investment, it's a project, there will be income and the operational expenses. So that net flow. Now the company is getting all income minus the expenses, relevant expenses. So that is the net flow, 15 million. So that 15 million is coming in this one as cash inflow. 15 million, 15, 15, 15, 15, 15. So that is the cash inflow for this investment analysis. Now the cash outflow. That is how much they have invested. They have invested rupees 60 million. Rupees 60 million. This is investment going out. So negative, we put it in bracket. Put it in bracket. Now, this says this machinery can be used for 12 years. But anyway, they want to dispose it after 5 years. After 5 years. So there will be a residual value. Machinery's residual value. So that also will come. That will come as the cash inflow because they are selling. At the end of 5th year, they are selling the machinery and they are getting. So we mention it residual value. Of machinery. Cash inflow. This is after the 5th year. At the end of, because still the machinery has to work till 31st of December to get the income. Then only the machinery can be disposed. So 24 million is coming at the after 5th year. Some people, they take this 24 million at the end of 5th year. They bring that one to the 5th year. But according to the World Bank calculations, World Bank work, this is in the following year. Here in the universities and various other institutions, they take this 24 million at the end of 5th year. So when the exams, if any student put this 24 million in the 5th year, okay, we won't cut the marks, but actually this 24 million, that is a residual value of the machinery, should come after 5th year. After 5th year. So it is in the 6th year. Right. $24 million. This is estimated at the okay. So now, so these are the inflow and the outflows. We take the net flow. 24.1. Net flow from the investment. Here 60 million. 15.0, 15.0, 15.0, 15.0, 15.0, 24 million. Now we see the total inflow will be 15, 15, 15, 15, 15. That is 1, 2, 3, 4, 5, 5, 15, 75 million plus 24 million. So 99 million total inflow, which is 24, 99 million. But they have invested only 60 million. So balnakotam hari lasanayini 60 million invest karla over the period of 6 years, they are getting 99 million. Yes, 99 million. They have invested 60 million, getting 99 million. Wonderful. Hari. Balnakotama, nigang balnakotama, yes, laksana vage, unda vage, peinde. Kalamu. What will happen? So what we have to do now? These are the future values. So we must bring the future values to the present value. We must bring each future value to the present value. We must bring it. So for that one, what we had to do, we must calculate the discounting factor and then multiply the discounting factor, the future values. So first we calculate the discounting factor. What is that? Calculating discounting factor at the rate of what rate we are going to calculate. So they wanted to borrow this one from a bank at the prevailing interest rate of 18% per annum. So we had to calculate at 18%. So you must 18% P. Discounting factor. So the set should be clearly written. When you do in the exam, when you do in your exam, when you get a problem like this, first of course, cash flow for the investment analysis, rupees billion, what currency you are doing it, that should be indicated. And then the step should be clearly written. Because the discounting factor, when the discounting factor differ, when the discounting rate is differ, discounting factor also will differ. So you must mention it is at 18% per annum. Okay. Now we go to this formula. PV is equal to future value into 1 divided by 1 plus R to the power n. So this is the discounting factor. So that is 1 divided by 1 plus R is 18%, 0.18, N is 1, say 0, this is now, so to the power 0. Here 1 is divided by 1 plus 0.18 to the power 1. Here 1 is divided by 1 plus 0.18 to the power 2. Then 1 divided by 1 plus 0.18 to the power 3. Then 1 divided by 1 plus 0.18 to the power 4. Then 1 divided by 1 plus 0.18 to the power 5. 1 divided by 1 plus 0.18 to the power 6. This is the discounting factor. At 18% discounting rate, this is the discounting factor. Discounting factor. First we have to calculate the discounting factor. Okay, now equal. So here this is 1. 1 plus 0.18 to the power 0 is really 1. So this is minus 60. This is okay. Now this one. We have to divide 1 divided by 1 plus 0.18. That is 1 divided by 1.18. So this is also a simple calculator. This is also with a simple calculator. 1, divide also when you put equal sign, hit divide and go in this one. So 1 divided by 1.18 equal sign, I am getting 0.847, and I make it for the easy calculation, I make it to two decimal, but in your exam you have to do it with 3 decimal. So here for the easy calculation 0.85. So here 0.85. This is the discounting factor for the first year. So again what I have to do? Again I have to divide by 1.18. So equal sign, put equal sign, you get 0.718. I put 0.7872. Again equal sign. So one more time, it will divide by 1.18 equal sign. 0.61 equal sign, 0.52 equal sign, 0.44 again equal sign, 0.37. So with a simple calculator you can calculate it. 1 divided by 1.18 first time equal sign, then con equal sign, again and again it will get divided. The answer will get divided by the 1.18 in this example. I have taken 2 decimal. So if you are taking 3 decimal, very good, yes. But in your exam, you have to do it with 3 decimal. If you go for 3 decimal, more accuracy, you will get more accurate answer. More accuracy. So this is the discounting factor. So now next, what is the step we have to do? Discounting factor we have calculated. Now you have to bring all these values, future values to the present value by calculating the discounting factor. By calculating the discounting factor, all these. So now the next step, you are converting it to present value. So PV, present value of the cash flow, at 18% PA per annum. So actually here it should be, sorry, here it should be, I have put 60. So here we have multiplied it, put here it is 1. Huh? Here this is also 1. 1 divided by 1, 1. Now multiply 60. Right, that is mine. So now multiply the future value by the relevant respective discounting factor. To convert it to present value. So 15 million into 0.85. I have calculated the 2 decimal. 12.75. Again 7.72 multiply 10.8. Again multiply 15 by 0.61. $9.15. Again multiply 15 by 0.52. 7.8. Again multiply 15 by 0.44. 6.6. Now multiply 24 by 0.37. 0.88. 8.88. 8.88. So this is the present value. We have converted all the future values to the present value by multiplying the respective discounting factor. Now all are in the same place. All are present values. This is the investment. This is the outflow present value. These are the inflows present values. Now this is equal to 60 minus, now you add up. All are same present value. Now we add up. 12.75 plus 10.8 plus 9.15 plus 7.8 plus 6.6 plus 8.88 plus 55.98. So now this is plus 55.98. So this is a negative value, this is a positive value, this is the income. So what is the difference? The difference between the cash outflow and the cash inflow. We call it, these are present values. When you take both together, then it is net present, net of present value. Net of present value. We call it NPV, net present value of the, this is the cash flow of the cash flow at, you have to mention 18% PA. Now, so minus 64.02. That is minus 4.02. Negative. Or you can put it in bracket, bracket, bracket. Negative 4 points. So NPV, you are getting a negative value. NPV, you are getting a negative value. So what do you mean? 7.8. What do you mean? This investment is not worthy. මුලින් බලනකොට මහා ලක්ෂණයි 60 million invest කරලා 99 million එනවා income ලස්සනයි කියලා කිව්වා මුලින් බලනකොටම පස්සේ when we do the discounting and bring all those future values to the present value and calculate කරනකොටම it comes as minus 4.02 negative value. When the NPV is negative, the project is not worthy. The investment is not worthy. When the NPV is negative, this investment at this interest rate is not worthy. So take it down. I hope you can see the board. You can understand my handwriting clearly. So you must understand the value of what do you mean by NPV. NPV is the net of the present value of the inflow and the cash flow. NPV means the net of the present value of the investment, of the inflow and the outflow of an investment cash flow. It is net NPV. So first we are converting. First we calculate the discounting factor. The meaning of discounting factor I told you, for the one rupee of future value, that is the present value. So first we calculate the discounting factor. Then we multiply the relevant future value by that discounting factor and converting that one to the present values. All the values to the present value, all future value we have converted to present value. That is the one PV, present value of the cash flow at 18% PA. Then we take the inflow and the outflow and find the net flow. Outflow is the investment, inflow is the income. Both are in present values. So all future value we have converted to the present value. So both are in present values. We are getting the net of it. We call it net present value and see whether it is positive or negative. And we see whether it is negative or positive. If it is positive, income is more than the investment in present value. When the NPV is positive, income is more than the investment in present value. So that means the project is worthy. If the NPV is negative, the income is less than the investment in present value. In other words, the investment does not cover the investment in present value. 99 million, 60 million investment, income 99 million. When you discount it and the income in present value does not cover the investment, it is loss. So if the NPV is positive, you can accept the project. If the NPV is negative, no, you can't accept the project because the income does not cover the investment in present value. So this is the steps should be clearly written, otherwise the marks will be cut. If what is the currency, if you don't mention, -1 mark. If the step is not properly written, -4 marks. So it will be cut. So steps and everything should be clearly mentioned. Okay, now, so what can we do? So the company is thinking. So if this investment at this interest rate is not worthy, so they negotiate with the bank. They are negotiating with the bank to reduce the interest. Okay, the bank has accepted, just for our calculation purpose. Bank agreed to give this facility at 13%. 13%. Okay, let us see whether it is worthy at 13% interest rate. So now we do it again on 13% interest rate. The bank has agreed to reduce it to 13%. So whether it is worthy. So now what we are going to do, we are going to redo it by discounting rate reduced to 13%. So I am erasing all these things. Other things will be same, but now this will be different. So this will become as 13%, this will become as 13%, and this will become as 13%. Now we are doing it 13%. So this is the cash flow is same. Now discounting factor at 13% per annum. Okay, so here 1 divided by 1 plus 0.18 to the power 0. Now, right? Now here 1 divided by 1 plus 0.1, sorry, 1 8 Navi, I'm sorry, 13. Now discounting rate is 13 plus 0.13 to the power 1. Here 1 divided by 1 plus 0.13 to the power 2. 1 divided by 1 plus 0.13 to the power 3. 1 divided by 1 plus 0.13 to the power 4. 1 divided by 1 plus 0.13 to the power 5. 1 divided by 1 plus 0.13 to the power 6. So now the discounting factor at 13%. So here this is 1 divided by 1 plus 0.13 to the power 0 is 1. So this is 1. Here discounting factor. Actually in the year 0, the discounting factor is the same. Same no, year 0 means now. So the money value PV is same. So it is 1 for this. So now next one. Use the calculator, ordinary calculator. I am using it. 1 divided by 1.13. 1 divided by 1.13 equal sign 0.0884. So 0.88. I am taking 2 decimal, not 0.88. Again, I am putting the equal sign. So automatically, this 0.88 will be divided by 1.13. Equal sign 0.78, not 0.78. Again equal sign, not 0.69. Again equal sign, not 0.61. Again equal sign, not 0.54. Again equal sign, not 0.48. Yeah, now this is the discounting factor at 13% per annum. 13% per annum. Now this is the discounting factor. 13% per annum. Now we have to convert each future value to the present value by multiplying the future value by the discounting factor. So now here, this is 1, so this is, you will get same 60 million negative. So now 15 million multiplied by 0.88, 13.2 multiplied by 0.78, 11.7 multiplied by 0.69, 10.35 multiplied by 0.61, 9.15 multiplied by 0.54, 8.1 multiplied by 0.48, sorry, 24 multiplied by 0.48, 11.52. So these are now converted to the present value. Or these are present values now. Separate PV, present value of the cash flow at 13% per annum. Now this is all are in present value. So now we must total income. So this is 60, that is negative, that's the cash outflow. Other one we see plus 13.2 plus 11.7 plus 10.35 plus 9.15 plus 8.1 plus 11.52 plus 64.02. 64.02. Well, now the cash inflow in present value is more than the cash outflow. So that will become as 64.02 minus 64.02 plus positive 4.02 positive. Well, now $4.02 positive. So since the NPV is positive, that means cash inflow, that is what is income in present value, is more than the cash flow, that is the investment in present value. So NPV is positive. So the project is worthy, investment is worthy, they can undertake at this particular interest rate of 13% per annum. So now it is at 18%, NPV was minus 4.02. At 13%, NPV is plus 4.02. Okay, fine. Please make a note. Please write. Now the time is 10:33. We have a break. We have a break. We meet by about 10:45. We meet by 10:45. We have a break now. Come back. Yes. Now let us continue. So here in this example, in the interest rate, that was the discounting rate was 18%, it is not worthy. The investment is not worthy. And when the interest rate is reduced, that is, discounting rate is reduced to 13%, it becomes worthy. NPV is positive, that we have seen. Okay, now I will erase this, but I want to keep one figure, that is this one. At 13% it is plus 4.02. At 18% it is minus 4.02. Okay, right. So I will erase it. You all have noted. Discounting rate %, at discounting rate 18%, the NPV is negative 4.02 minus 4.02. And at 13%, NPV is positive 4.0. The difference is 5% difference. So this we have calculated. In the last example, we have calculated. I hope it's very clear. So, when the discounting rate from 18% to change to 13%, this shifts from minus to become positive. From negative, it became positive. From negative 4.02 to positive 4.02. So, in between, at certain point, what is happening? This negative value changing into positive value. So negative value would have come to 4.02, then 4, maybe 3, maybe 2, maybe 1, maybe 0. And then 1, 2, 3, 4. So there is a point where the NPV may be 0. NPV may be 0. I hope you understand. So when the discounting rate is reducing from 18 to 13, maybe 18, 17, 16, 15, 14, 13. When it is getting reduced, the NPV also changing from negative value to positive value. At certain state, this neither negative nor positive, the NPV may be 0. At what point, at what discounting rate, this may be 0. The NPV will become 0. Since it is changing, very simple to understand. Yeah, it will become 0. So at that point, it will become 0. So you can plot a graph. Here we take NPV in this axis. Here it is positive value. Here it is negative value. In this axis, we take discounting rate. Here it is 0. Here it is positive, negative. Here NPV is 0. So here the discounting rate also from start from 0 is going maybe at 18%. Here it is maybe 18%. It is NPV 0. NPV is negative. NPV is negative. 18%. NPV is negative. So here maybe negative. And 13% discounting rate 13%. NPV is positive. Somewhere here. So when the discounting rate is increasing, it becomes negative. This may come so when you take NPV for different discounting rate and plot a graph, the graph may be like this. When you take NPV for different discounting rates and plot a graph, and this point, it is negative. So it is 0. NPV is 0. Neither positive, nor the negative. It is not negative or no positive. It is 0. This point is also important. We call this point as internal rate of return. IRR. This point is called as internal rate of return. The internal rate of return is the NBV. When you plot NBV for various discounting rate, the point where the NBV is neither positive nor negative. That point, that discounting rate is called as IRR. IRR is a discounting rate where the NPV is neither positive nor negative. Please take it down, plot the graph, and take it down, plot the graph, and take it down. IRR, internal rate of return, is the discounting rate. The discounting rate where the NPV is neither positive nor negative. So, if the interest rate, borrowing interest rate is equal to IRR, the project is neither positive nor negative, no gain, no loss, no profit, no loss point. The investment is no loss, no loss, no gain, no profit point. That is the IRR, where the interest rate is equal to IRR, means the investment is no loss, no profit. It is a break-even point for the investment. It is a break-even point for the investment. That is the IRR. Internal rate of return. Now, so how to calculate? Now, one way is plotting the graph, you can calculate the internal rate of return. So when you when you do an investment, and if you are borrowing, your borrowing rate should be less than the IRR. Then only it will be profitable. Your borrowing rate should be less than the IRR. This point. Then only your investment will be profitable. If your borrowing rate is more than the IRR, then it is loss. So, another way of deciding the project or the investment, the borrowing rate should be less than the IRR. That is one. Other one is the NPV should be positive. That is another thing. So either the NPV should be positive or the borrowing rate should be less than the IRR. Then only the project is worthy. The investment is worthy. Okay. So now one way plotting the graph. And there is a formula also you can apply. There's a formula to calculate the IRR. What is the formula? We are taking down, I am guessing it. IRR is equal to lowest discount rate. Lowest discount rate. In this example, so you must have two discount rates because the IRR will be in between the two discount rates. So obviously you have to do calculate the NPV in two discount rates. In two discount rates, you have to calculate. One is lowest discount rate, other one is the highest discount rate. So here in this example, what we have done is like that. The lowest discount rate is 13%. That is 13%. And I told you two discount rates. Lowest discount rate plus difference between two discount rates. Difference between two discount rates. So in this example, the difference between two here percentage and 13. Difference between two discount rate, one is 18, other one is 13. So the difference between two discount rate 5. So 5. Then into bracket NPV at the NPV at the NPV of the cash flow. No, we are doing cash flow. At the lowest discount rate. NPV of the cash flow at the lowest discount rate. So here, bracket NPV of the cash flow at the lowest discount rate, that is plus 4.0. 4.0 divided by total of the NPVs of the cash flow. Total of the cash flow. Total of the sum of the total or sum of the. They use the word sum. Sum means total. Sum of the NPV of the cash flows at two different discount rates. Two different discounts rates. Bracket close. Here the one thing you have to see, sum of the NPV of the cash flow at two different discount rates. In this example, two discount rates, that means 18%, other one is 13%. In the 18%, the NPV is negative 4.02. In the 13% discount rate, the NPV is plus 4.02. If you take the sum, what will happen? Totally, what will happen? Minus 4.2, then plus 4.02. What will happen? 0. If it is 0, what will happen? Any number below 0, it is infinity. Any number divided by 0, it will be infinity. It will be infinity. So what we have to do, ignore the signs. Ignore IGNOR. Ignore the signs. SIGNS bracket. Ignore the signs. Signs amata karla danda metana vitarai. So no positive, no negative. 4.02 sum total 4.02 plus 4.02 8.04. So sum here 4.02 plus 4.02. So this is equal to 13. No other, right? Plus 5 into 4.02 divided by 4.02 plus 4.02, 8.04. 8.04. I will rewrite product. I will resistant product, put it up, going to clear. So this is the formula. So this will come. IRR is equal to lowest rate is 13% plus difference between both rate 13 and 18, 5. So multiply into bracket lowest NBV at the lowest discount rate, that is 4.02, divided by sum of the NBVs at the two different discount rates, that is 4.02 plus 4.02. Ignore the sign negative, positive. You think that will 4.02 plus 4.02 bracket close. This is equal to 13 plus 5 into 4.02 plus 4.02 divided by 8.04. This is equal to 13 plus 5 into, this is 0.5. 4.02 divided by 8.04, 0.5. This is equal to 13 plus 5 into 0.5, 2.5. So this is equal to 15.5. Okay, yes, 15.5. That is the IRR. This is the discounting rate in between 13% and 18%. This is the discounting rate between 13% and 18%, 15.5. At this rate this is the rate IRR. If they borrow at this rate, there is no loss, no profit for the company. The company won't make any profit. It won't make any loss also if they borrow at this 15.5. That is the IRR. So this is the formula. Once again, IRR is equal to lowest discount rate plus difference between two discount rates, that is 13% and 18%. And into multiply NPV of the cash flow at lowest discount rate at 13%, but it's a NPV. Then divided by sum of the NPV of the cash flow at two different discount rates. At 18%, what is the discount rate? At 18%, what is the NPV? At 13%, what is the NPV? Sum of them. Ignore the sign. Signs, if you don't ignore the sign, it's a problem. So ignore the sign. Take the total sum. So 4.02 plus 4.02. That is 8.04. And here it is in the bracket. Basically, first image, things like that. What you have to solve, what is within the bracket, you have to solve. So you have to solve this one. 4.02 divided by 4.02 plus 4.02, that is 8.04. So 4.02 divided by 8.04, 0.5. First you solve within the bracket, 0.5. And then multiply by 5. Second one, first you solve within the bracket, then do multiplication, then do division, then do addition, then do negative. So 0.5 into 5 plus 13. So this is 2.5 plus 13, 15.5. This is the IRR in this calculation. This is the IRR in this calculation. So now you know about IRR also. So once again, you know the meaning of time value of money. You know the meaning of present value. You know the meaning of future value. You know the meaning of compounding. You know the meaning of compounding rate. You know the meaning of compounding factor. then you know the meaning of discounting, you know the meaning of discounting rate, you know the meaning of discounting factor, and you know the meaning of net present value, NPV, you know the meaning of IRR, internal rate of return. There is another term, discounted cash flow. What do you mean by discounted cash flow? When discounting is applied to a cash flow, that cash flow is called as discounted cash flow. When discounting technique is applied to a cash flow to convert future value into present value, that cash flow is called as discounted cash flow. Please take it down. When, put the heading, discounted cash flow. When discounting technique is applied, when discounting technique is applied to a cash flow to convert the future values of the cash flow to present value, that cash flow is called as discounted cash flow. Discounted cash flow. So now you know basically everything related to the time value of money. So IRR, everything. I hope it is clear to everyone. Right. So now, so here to calculate the IRR, you need two different discount rates and two different NPVs. You need two different discount rates. You need two different relevant NPVs minimum. Yeah. So those days we were doing it manually with just a calculator like this. This calculator technique was introduced by the World Bank, EDI. EDI means Economic Development Institute. Economic Development Institute. EDI. The World Bank. Economic Development Institute, they only introduced this simple calculator, how to use in the discounting, in these techniques, how to use this one. They only, yeah. There was a very good person who was managing this economic development, Mr. Price Kittinger. Price Kittinger, Kittinger. Mr. Price Kittinger. He has wrote a book. The name of the book, Economic Appraisal of Agricultural Projects. Economic Appraisal of Agricultural Projects. It's a very, very elaborate book, very good book. If you happen to read that book, of course, you can really drastically, you can expand your knowledge. A very, very useful book. Very, very useful book. It's a Price teacher. He was a lecturer with the World Bank Economic Development Institute. He only wrote that book. Maybe others would have assisted him, but his name was there in the book. Yeah. There are only this time value of money. Very elaborately he has given. In detail. If you happen to read this book, you can really increase your knowledge. Anyway, right. So we were using this calculator. At the time, no computers also, using this calculator. So you must know. So for a project, when you want to calculate the IRR, minimum two discounting rate, and then relevant NPVs you have to calculate. Then only you can calculate the IRR. So sometimes when you are doing manually, no computers, with this calculator. Sometimes, yeah, we start from say maybe 18%. We start discounting rate, 18%. Then the NPV maybe minus. So we take 5 difference of 13%. NPV again minus, again 5%. So 8% different. With the difference of 5%, we were doing. With the difference of 5%, we may get positive. So you have to do trial and error method. We were doing trial and error method for this calculation. For the NPV, of course, no problem, you can calculate, but the IRR, sometimes 4 or 5 times we had to do this calculation. Different discounting rate, relevant NPV. About 4 or 5 times, then only you will struck the IRR. So you are doing like that. This is manually, but now you have computers. You have scientific calculators. So we were doing only with these simple calculators. We were doing this. How to use this calculator also given in Price Kittinger's book. They have conducted a training program in Colombo, but actually, first of all, they have started this EDI project analysis appraisal was started in Washington. So many people, our senior people, they attended that one, and then they have conducted in India, and finally they have conducted in a small way in Colombo also. I was lucky to follow that program conducted by the EDI in Colombo. I was really lucky to follow that program. Anyway, so but you have to do the trial and error method. Maybe 4 or 5 times you have to do it with a simple calculator. But now you have the computer. You can use the computer easily to find out, calculate the NPV or IRR. How to use the computer. NPV. Now, maybe investment that is negative. The year 0, then 1, 2, 3, 4, 5 years. Here you will have value. Here value. You have the value. So this is the normal cash flow. Cash flow. This is going to be the net cash flow. This is the net cash flow. So you have to get the net cash flow. So there will be a negative value and then the positive values. You will have net cash flow. You have. So in the Excel program, you know Excel program, there's an Excel sheet, spreadsheet, Excel sheet you have. So in the Excel sheet, you have to put this net cash flow of the project or the investment. Net cash flow of the project or the investment, you have to put in. So there will be a negative value, obviously, the investment, and then positive value is the net cash flow. It is not the discounted cash flow. You know how to do the discounted. Computer will do it for you. Computer will do everything for you. This is your normal net cash flow. Then in the Excel cell, keep the cursor. This is the Excel sheet. Cell. So keep the cell, keep the cursor, put a equal sign. Then the computer will prompt. You know to keep it in your mind also, computer will prompt. The bracket, for the NPV calculation, it will tell you range. What is the range? Ask the range. Range. Ask the range. So you take the cursor to this place, nail down, fix it. Take the cursor to this point, this one, fix it. And then highlight the range. Highlight the range. Oh, here the range. You have highlighted the range. Then put the comma, put a comma. And then the computer asks, what is the discounting rate? What is the discounting rate? So, at what rate you want to discount? Mention 0.18 in decimal. 0.18, 18%. 4.12, 12%. 4.1, 10%. 4.14, 14%. Whatever the rate, whatever the discount rate, you are going to discount it, you are going to do it. So, discount rate. Subtract. And then enter. You will get the answer. The NPV you will get. You will get the NPV. Once again, I will repeat. So, in the Excel sheet, in the Excel spreadsheet, you put the normal cash flow, that is net cash flow. You put the net cash flow, that is the negative, and then the positive values. Right, net cash flow is there, and then take the cursor to the cell, put an equal sign, and send NPV. Sorry, I didn't mention that one. Put an equal sign and send NPV. Put the bracket. Then the computer will ask, what is the range? What is the range? Computer will ask, what is the range? NPV, right? Then you take the cursor to the range. Here you fix it first. Otherwise, when you move the whole cursor will move. So you fix it. You can fix it. And then highlight. Then the area will get highlighted. The cursor. Put a comma. And then put a comma. So here it will, range will come. Then it will ask what is the discounted rate. You give the discounted rate. Discount rate. Discount rate. Bracket close. And there you will get the answer. What is the NPV? It is negative or positive. Answer you will get. Depend on that one. If it is positive, you may decide it's a worthy project. If it is negative, not worthy project. So now, very simple. You don't need to do all these calculations and everything. Very simply use this computer. You will get the answer. But so why I am teaching this, you should know what is the basis. You know what is the basis. Now it is easy. That is the thing. System, the computer systems and everything. Because of that, people are not learning. People are not learning. Because the computer is doing. At last, the computer will instruct us. So now, you must know what is the basis behind that one. What is the basis? You must know. Right. So this is the one. So next one, IRR. IRR. For the IRR also, you must have the cash flow. Net cash flow you must have. You must have the net cash flow. Then you take the cursor to the cell, put equal sign, then IRR. The bracket. Computer will ask what is the range. So take the cursor here, as I told you earlier, fix it and highlight and put a comma. Cursor will come here. Then the computer will suggest a rate. Some rate. Suggest a rate. Computer will ask you to suggest a rate. So say maybe 13%, 15%, 18%, any rate you mention, maybe, yeah, but in decimal, 0.12. Close the bracket, enter. You will get the IRR for this cash flow. You will get the IRR for this cash flow. So all simplified by using the Excel. You can calculate without doing much work. You can calculate the IRR. You can calculate the NPV. Right. So this is one thing. And then when you do this IRR or NPV calculations, NPV calculation. Right. I tell you now this IRR and NPV in computers from different what is it? The Excel, of course, Excel, they are improving it, no? They are Excel, yeah, different version. Different version. Sometimes this may differ. The Excel version, different versions, what I said you may slightly different. There may be slight difference depending on the different version. So when you are using a particular version, apply that formula, what I told you. Yes. So different versions, there may be some slight difference. That for your information I have told you. So Excel also, because they are improving, they are changing. They are improving and they are changing. So that may, right. So now another thing. When you do this what is it, IRR or NPV, discounted cash flow, there should be a uniformity. When you are taking the project period, I told you year 0, year 1, year 2, year 3, yeah. There should be a uniformity. If one you are taking yearly basis, then it should be everything should be yearly basis. The cash flow, when you are taking the cash flow on yearly basis, then everything should be yearly basis. If you are taking half yearly basis, everything should be a half yearly basis. If you are taking quarterly basis, everything should be quarterly basis. Because now, since you are the computers, it is easy for you to calculate. The earlier, of course, with manually, then of course, yearly basis. We are doing everything on yearly basis, manually. On yearly basis only we were doing. But now you can do it either yearly basis, half yearly basis, quarterly basis, even monthly basis. The computer, if you take a computer, so many things, monthly basis. But uniformity should be there. And another thing, when you are taking yearly basis, the interest rate, discounting rate or compounding rate, that is the interest rate, should be yearly interest rate in decimal. If you are taking half yearly basis, the interest rate should be in half yearly decimal. If you are doing on quarterly basis, the interest rate should be in decimal quarterly interest decimal. Keep it in your mind. So everything should be uniformity should be maintained in this calculation. There should be uniformity, either yearly basis or half yearly basis or quarterly basis. Yes, but interest rate also you must change accordingly. So from yearly basis, when you want to do it half yearly basis, the interest rate, yearly interest rate divided by 2 and put it in decimal. This is very simple. Okay, you have to do it. Right. That is one thing. Yeah, now the question number 5. This one, please. Question number 5. The question, ABC Plastic Company Limited has planned to install 2 numbers blow molding machines, plastic company, blow molding and injector molding machine. There are 2 techniques the plastic they are using, blow molding technique, and another one is injector molding technique, depending on type of plastic product they are producing. So here they are using blow molding machines to increase its production capacity of plastic items at a cost of rupees 8 million. So investment is 8 million. The cost of installation and other expenses will be rupees 500,000. So the machinery, now they have to install it. So that is around 500,000 investment. Investment on working capital for this venture will be 3.5 million. So there are three types of investment. One is investment on machinery, and then investment on installation and test running, etc., and investment on working capital. Right. The company plans to produce 150,000 units of plastic item annually from both machines. So both machines together. So one cash flow is okay for both machines. For both machines. And it is estimated that each unit will contribute a net cash flow of rupees 25. Net cash flow of 25. The economic production life of both machines is 5 years, and the machine will have the residual value of rupees 1 million after the period. So the machine will be used only for five years. After that, it will be sold out. It has a residual value of 1 million. The company plans to meet the entire investment cost through a bank borrowing at an interest rate of 14% per annum. Based on the concept of time value of money, carry out an analysis and confirm whether the investment is acceptable or not. Give you a reason. So the income will be generated by selling the plastic annually 150 units, 150,000 units. Each will contribute a net cash flow of 25 rupees. Each will contribute a net cash flow of 25 rupees. So, same cash flow for investment, appraisal, cash flow for investment. Cash flow for investment, appraisal or analysis, cash flow for investment, analysis. And then the currency, it is rupees million. We do it in million. Right. In the project year, zero. Now 1, 2, 3, 4, 5. We are going to sell the machinery. The residual value 6. So now cash inflow. First cash inflow. Annually 150,000 units. Annually they are producing, selling kind of. Each will 25 rupees. Each will contribute a net cash flow of 25 rupees. So, under 50,000 into 25. Around 50,000 into 25. $3.75 million. 3.75 million. 3.75, 3.75, 3.75, 3.75 million, 3.75 million. Up to 5 years only there. Then, so this is each unit contribute a net cash flow of 25 rupees. That is to produce. What is the cost of the raw material, electricity, power and use, then workers, labor and everything? Yes. So you have to reduce it from the income, from the sales price. They reduce. That is the net cash flow from each unit. So that is coming as the cash inflow here. The net cash flow of that each unit 25 rupees coming as the cash flow in this one, in the cash flow for the investment analysis. Now the cash outflow. Investment on machinery. ₹8 million. Cost of installation 500,000. Working capital 3.5 million. $8 million. And then installation 500,000, that is 0.5 million. Then working capital 3.5 million. 3.5 million. Working capital also investment, lifelong, as long as the project runs, the working capital will be there. It is a long-term investment. Should be financed by a long-term facility.
So working capital you consider as in the first year itself, total working capital.
Sorry?
Total working capital you consider under first year itself, in full.
Yeah, correct. Yes, total working capital. Yes, either way, either as an investment in the year 0 or year 1 also you can consider. That is correct. Year 1 also you can consider. That's right. Total working capital. Yes. Okay. But here, either in the year 0 or in the year 1 also you can consider. Right. So this is the working capital. This is a lifelong. This is as long as the project runs, the working capital will be tied up there. It's a long-term investment. Then, right, what else is the working capital? And then machinery will be sold after 5 years. After 5 years, the machinery, it has a residual value. The residual value is 1 million rupees. So that is the inflow. Inflow by selling inflow dash residual value. So otherwise you can write residual value of the machinery, residual value. Of machinery $1.0 million. And now the working capital, what happened to the working capital? You are investing So working capital is revolving within the business, within the industry. And when you close down the business, close down the industry, the working capital will be recovered. When you close down, so the working capital also will be recovered. Working capital recovery. Working capital recovery. That is also after the project. Working capital 0.5 million. These are positive value. These are the negative value. Now the net flow. Yes.
So working capital 3.5 million, right?
Sorry.
Your recovery of working capital 0.5 million, is that correct?
Yeah, you will recover at the end of the project. When you close down everything, the working capital will be there. You convert into cash.
Yeah, so that should be 3.5 then.
Yes.
Now in your sum, it's you put at 0.5 on the board.
I couldn't follow. What is it?
On the board, you have make it at 0.5.
Yeah. Now, actually, we are investing now 3.5 million, and that 3.5 million we will be recovering it.
Yeah, correct. But you have put as 0.5 on the board.
Sorry, it is not clear to me. Anyway, you give me a call. You give me a call, please. Huh?
Now, what you have mentioned in this in the board that you have written is 0.5 million.
This 3.5 million, the working capital, here we are investing.
Recovery also should be the same amount, right?
Sorry?
Working capital recovery amount also should be 3.5, right?
Yeah, that's right. Yes.
Yes, but you have written only 0.5 million as recovery amount.
The tables.
On the table that you have done.
On the table?
No, on the table that you have written on the board, you have written as 0.5 million.
0.5. Sorry, I couldn't follow.
Sir, on the board you have written a table of cash flow analysis. There you have put it as 0.5.
I'm sorry. Okay. Thank you very much. Thank you.
Okay.
Thank you. I'm sorry. Right. So now the net flow. Here 3.5 plus 5.4 plus 12 million. 12.0 negative, then 3.75, then 3.75, then 3.75, 3.75, 3.75, here 4.5. This is the net cash flow now. Now we have the net cash flow. So to see whether this investment is worthy, what we had to do, we had to do a discounted. We had to do a discounting and convert this into a discounted cash flow. So once again, these are the investment by your machinery, then installation, and the working capital 3.5. Actually, some people they take this 3.5 to the year 1 also, because year 1 only the business is started, the production is starting. So that's also possible. You can do that like that way also. 3.5 million you can take it to the first year. First year also you can do. But here, this one I am doing it in the 3.5 in the year 0. I am taking as the investment. And then these two, the installation, no. The machinery, the residual value will come as 1 million at 6 years, and 3.5 working capital recovery you will recover. Now, because working capital is revolving, it is there. It is a permanent investment. It will be recovered. It will be recovered 3.5 million. So this is the final net cash flow. Now you have to do the discounting. Please, you better do the discounting. At what rate they plan to borrow? They are planning to borrow at 14% per annum. So discount at 14% per annum. So first one, discount factor. Discount factor at 14% PA. One divided by 1 point plus 1/4 to the power 0. Yes, 0. Then 1 divided by 1 plus 0.14 to the power 1. 1 divided by 1 plus 0.14 to the power 2. 1 divided by 1 plus 0.14 to the power 3. 1 divided by 1 plus 0.14 to the power 4. 1 divided by 1 plus 0.14 to the power 5. 1 divided by 1 plus 0.14 to the power 6. So when you do it, equal to this discounting factor is 1. 1 divided plus 1 plus 0.14 to the power 0 is 1. In the other one, the simple way you do it, 1 divided by 1.14, 1.14 equal 0.877. I put it as 0.88, not 0.88. Again, equal sign, not 0.77. Again, equal sign, not 0.67. Again, equal sign, not 0.15, not 0.59. Again, equal sign, not 0.52. Again, equal sign, not 0.46. So now next one, now you have the discounting factor. What we have to do, we have to multiply the cash flow by the respective discounting factor. And the sentence is present value. We are converting present value of the cash flow at 14% PA discounting rate. PV of the cash flow. Now we are converting the cash flow. PV. PV of the cash flow at 14% discounting rate. So here 12.0 negative, then 3.75 into 3.75 into 0.88, 3.3, then 0.77 multiply 2.88 or 2.9. I say 2.9. I decimal. Then 0.67, 2.5, then 0.59, 2.2, then 0.52, multiply 1.95, then 4.5 multiplied by 0.46, 2.07. So this is the PV of the income, PV of the inflow, PV of the inflow. So total it up and see. So this again negative 12.0. In other, oh, yeah, 3.3 plus 2.9 plus 2.5 plus 2.2 plus 1.95 plus 2.07, 14.92, 14.92. That is, this is plus. So the NPV of the cash flow is NPV of the cash flow at discounting rate of 14% per annum. So this is 14.92 minus 12. 2.92. This will be 12, 2.92. So NPV is positive. NPV is positive. So this investment is worthy. So this investment is worthy. NPV is positive. The step should be clearly written. You must learn, yeah. The step should be clearly written. Okay. What is the IRR for this investment? What is the IRR for this investment? What do we have to do? What is the investment for this IRR? What we have to do? We have to calculate the NPV at different discounting rate, different interest rate. Since at 14 this is positive, since at 14 this is positive, what we have to do? We have to increase the discount rate and see. Now it is at 14%, we are getting plus 2.92. So we have to increase, maybe say using 5% difference, 19%. At 19%, what is the NPV? You have to calculate. If it is negative, then very good. You use both values. By applying the formula, you can calculate the NPV, sorry, IRR. If it is again positive, again you have to increase the discounting rate from 19 plus 5, that is 24%. You have to calculate that 24% interest rate or discounting rate, calculate the NPV. That is, you have to calculate till you get negative value, negative of NPV. You have to calculate till you get negative NPV. You change the discounting rate, that is, you increase the discounting rate and calculate that NPV till you get negative. Then you use both values, you can calculate the IRR. Okay, that of course you can do it yourself. I don't need to, because now you know how to do it, how to calculate the NPV, how to calculate the IRR. Now you know. So I don't need to do it again. You can do it. Okay, right. You do it yourself, maybe at home, yes. Now, question number 4, this is purely a theory question. Question number 4. So you should know theory also well. Now you should know. You understand. If you understand, yes, you should know. What do you understand? Question number 4. What do you understand by the following in regard to financial investment appraisal? Financial investment appraisal. We can call it capital budgeting. Also, one way. Yeah, of projects. Few explanatory sentences for each item would be sufficient, and wherever possible, give examples. So in this type of question, please give the examples. That means you understand well. We will know that you understand well. Please give the example. Time value of money, present value, and future value. The first one. Second one, discounting rate, discounting factor, discounted cash flow. We have done today. Net present value of projects, of projected cash flow, and its interpretation. NPV, yeah, its interpretation. We have when it is positive word, when it is negative word, how it is coming positive, how it is coming negative, what is in interpretation you must give. Then internal rate of return of a projected cash flow and its interpretation. What even IRR is, yes, positive word, negative word, right? When what is it? So 0, when it is 0, what is the interpretation? Right. Then the calculating IRR using Excel computer application. Everything we have done. Everything we have done, so you know. Right. Now we come to the question number 2. Question number 2. This is something different. Question number 2. I am reading the question. Briefly explain the meaning of following. Time value of money? Yes. Net present value. Right. ABC International Limited is an engineering company and has decided to install a new plant at its Colombo factory to manufacture engineering tools for marketing in Sri Lanka. The cost of the plant and the machinery will be rupees 50 million. The cost of installation, training of workers, test running, and other expenses will be rupees 3 million. And it will take a period of 4 months. Yeah, so the investment here, the machinery is an investment, cash outflow, then installation, then training of staff, all those test running, all those are investment. So those are investment, cash outflow. Then there is another investment on working capital. Yeah, that is 12 million. That is also investment. So all these are cost of the machinery, then installation, test running, training of staff, and plus the working capital, all are investment cash outflows. Right. Out of that one, machinery sometimes it may have a residual value. At the end, you can get as an inflow. But the installation and other things you won't get an inflow. At the end, of course, that is once and for all, yes, that is expenses. That you won't get any inflow back. No. Working capital, yes, at the end you will get the inflow back. And another difference, we have mentioned it is 4 months. It will take 4 months and the commercial production starts after 4 months. So people may get confused. Right. Now, actually, if you are doing the 4 months, the investment is on the basis of 4 months, the whole period, you have to do it on a 4-month basis. I have told you, if you are doing in yearly basis, everything should be yearly basis. If you are doing half-yearly basis, everything should be half-yearly basis. If you are doing quarterly basis, everything should be quarterly basis. If you are doing monthly basis, everything should be monthly basis. So if you want to do it in 4-month basis, everything should be 4-month basis. You have to do till the end of the project. But instead of that one here, the here 0 you can take this 4 months as the year 0. The 4 months as the year 0. And the year 1 start with the commercial production. That will go for every 12 months, 12 months, 12 months. So the year 0 also 12 months. So in that 12 months, the investment you are accommodating. Okay. So don't get any confusion. Yeah, here the year 0 itself, this investment, everything will come. That is, though it is 4 months, you consider it is year 0, full 12 months. And then your commercial production start year 1. On that basis, you do it. If you try to do it 4 month basis, then it is very difficult for you to do in an exam. Maybe on a project analysis as an analysis, when you do it. But with the computer, obviously you can easily do it. With the computer, easily do it. But in the exam, you consider this 4 months as the year 0. Don't have any confusion. Year 0. When we do it manually, those days, we do like that. So, though it is 4 months or 5 months or 6 months, we do it year 0. And then year 1 with the commercial production we start. 12 months, 12 months, 12 months, it goes on. In the exam, of course, don't try to do it. It will be a problem for you. When you practically, when you are doing as a project analysis, when you do it, you can do it with the assistance of computer. You can do it easily. In the exam, once again, I am telling you here, though it is 4 months, you consider it as year 0 and do. I hope you understand. Right. And then one more thing I have to tell you. We are doing all these things on market prices. All these prices, 3.75 billion income and 8 billion machinery cost and installation cost of everything. Market prices. Market prices. So the IRR, what we are calculating, is known as financial internal rate of return. FIRR. FIRR. Financial internal rate of return. FIRR. So we are doing everything on the market prices, everything on the market prices. But there is another calculation on economic prices. Market prices and economic prices, there is difference. So when you do this IRR calculation in economic prices, we call it EIRR, IRR, economic rate of return. So both there is difference. One is FIRR on financial, that is market prices, and other one EIRR on economic prices. So first you do the FIRR, calculate FIRR, and then convert the market prices to economic prices. First you do market prices, there you calculate the FIRR, then convert the market prices to economic prices and do the same way, calculate the EIRR. So how to convert market prices to economic prices, we are not doing here. Very basic, we are not doing in this session. That is by using border prices and shadow pricing method. There are two methods, shadow pricing and border pricing method. You convert the market prices to economic prices and then calculate the economic IRR. especially the SME projects, when with the foreign funded foreign funded SME projects, they are asking for the EIRR. In the banks, the appraisal officer should know both FIRR calculation as well as EIRR calculation. They have to do it. But in this one, we are doing only FIRR. EIRR, for your information, I am telling you, we are not doing EIRR. Maybe the time factor is another reason. So EIRR, you convert the market prices into economic prices by using border price method or shadow price method, and then calculate. Then the calculation is same. Even with the computer, you have the cash flow, and then you can do it. It's same. The only thing you have to learn, convert the market prices to border prices and the shadow prices, economic prices, by using border pricing and shadow pricing method. Okay. This information I have given you. So if you happen to go through this Price Kitchenger's book, it is very good. You can learn a lot. Hope you all would have understood about this time value of money and this discounted cash flow and everything. If you have any doubt, you can give me a call at any time. Maybe I would have given you my telephone number, but anyway, I must thank the person who that working capital. I have mentioned 0.5, but again, I couldn't get that one. What he was telling, 3.5 for correcting me. I am really thankful to you. Thank you very much. Maybe I would have given my phone number to you or your batch earlier. Maybe if you have any doubt or anything, you can contact me with this number. Maybe sometime this residual value. Some people, they now, if the project is going for 5 years, after the project only they will sell the machinery. So in our case, of course, even in the World Bank project, they take it in the following year. If it is 5 years, the project period, the 6th year, that income, they will consider as an inflow. But here, I think Colombo University and some Institute of Accountants, they consider in the same year, 5th year itself. But if your answer is both way, of course, I won't penalize you. I must tell you, yes. Similarly, the working capital, we are taking working capital investment, we are taking in the year 0. But some people, they take year 1 also, that's also correct. Year 1 also, some people take the working capital investment. Other investment in the year 0, that is machinery and installation of those investment in the year 0. But the working capital, you can take it in year 0 or year 1 also, you can consider that one, right? So if you, I won't penalize if you either this way or that way you write, I won't penalize you. But only thing, steps and working should be very clear. Steps and working should be very, very clear. And if you miss that, what is the currency value, and if you don't mention, yes, definitely 1 mark. If the step is not written properly, minus marks, minus 4 marks. First, of course, I give the full marks, 18 marks if there is 18 A's given. And then 1 by 1, I reduce. So sometimes the whole 18 maybe get cut off. So if you want to preserve that 18, correctly write everything. Okay, right. Thank you very much. Maybe I may have one more lecture with you all. Maybe I may meet. Yeah. Okay. Thank you very much. If you have any doubt, you can speak to me. Thank you. Thank you very much. Let us close down. Yeah.